everybody, Miss Maritello here. So I just wanted to give a little introduction to interval notation. So what'll happen for interval notation, sometimes we'll be given a set, something that'll kind of look something like this. When you see this notation, you would read it as the set of all x such that x is greater than 3. So basically all that really means is just that we have a bunch of numbers that would be included in this set, and they should all be bigger than 3. Notice that it's just greater than 3. We don't have the little line underneath it for greater than or equal to, so we wouldn't be allowed to include the number 3 in our set. It would be, you could have 3.1, you could have 3.2, you could even have like 3.01, but that number 3 would not be included in this set. And again, it's those fancy brackets or braces that we would call like the set, or the notation just for saying that it's a set, and then that line in there means such that. When we look at this, though, when we change it to be interval notation, the first thing that I really like to do if we're given something like this is go ahead and graph that inequality like you would have when you solved inequalities. So if you were given x is greater than 3, we know that we need to have an open circle on the 3 because, again, we're not including it in our answer, but then we would include everything bigger than 3. So we're kind of shading to the right of 3 because that's where 4, 5, 6, all the way to infinity would be. We could have 100, we could have 1,000,000, all those numbers would be shaded. Once we see that, that's where kind of the interval notation starts to come in. So interval notation is basically just another way of writing that number line. So to show that we're not including the 3, we're going to write a parentheses with the 3. And then for the biggest part of the number, kind of like where we're going, we know that the interval goes all the way to infinity in this case. So we're going to put that little symbol there for infinity. And then technically, I'm not able to include infinity either because I don't know what number it is. So we also put a parentheses with the infinity. So this notation, the parentheses around the 3 to infinity, means the same thing as the number line. So like this is also saying 3 to infinity would be my solution. Meaning that like 4 would be a solution, 10 would be a solution, 100, 1,000, 1,000,000, 10 billion. All those numbers would be solution. You could have fractions, you could have pi in there, everything in between 3 all the way to infinity. But just that parentheses tells us that we're not including the 3. So if I see something like this then, kind of similar, except for now I'm looking at x is less than 5. So if you want to do your graph, it should look like that. Again, we have an open dot because we don't have the or equal to, we just have less than. So then this one, we're shading to the left, we're shading smaller numbers like 0, like negatives, 4, 1. So then for this one, instead of going to infinity, we would be going to negative infinity. So we're technically starting at negative infinity and then going to 5. And again, we cannot include the 5 because we have the open circle. And then we're also not able to include negative infinity because we don't officially know what number that is. A big common mistake that kids make with this one is sometimes they write it as 5 to negative infinity. Technically, that's not allowed. Like you figure if your school day goes from 8 to 3, you wouldn't say it goes from 3 to 8. So like it has to be in the same order that the number line is. So that 5 to negative infinity, that's not okay. So that would be like considered to be incorrect. It has to go the same order that the number line is, the most negative numbers first to the bigger numbers. If you were to see something like this, again, I highly suggest that you would make the little number line graph first, especially as you're new with interval notation. On this one, we have the open dots on both 5 and 10 because we don't have the or equal to on there. So then we would be shading in between 5 and 10. So on this one, then when we go to write our interval notation, and we won't have an infinity on there because we're not shading to infinity on either side. So you would just have from 5 to 10 in there, and you'd have the parentheses on both sides to show that you're not including 5 or 10. And then kind of notice again, it looks kind of like an ordered pair because of the parentheses, but it's not. This would be considered to be an interval. It would include 5.1, it would include 9.9, 7, anything in between 5 and 10, but not including 5 or 10. And finally, we got one that has the or equal to on there. So here we got the set of all x such that x is less than or equal to 10. If you were to draw your little graph on there, you would have now a closed dot on 10, and then you'd be shading everything to the left of it. And then similar to the other ones, we'd be starting with the negative infinity. We have to use the parentheses because we can't include it because we don't know what number negative infinity is. But then because I have this closed dot on 10, because it's including it, I use the bracket to show that I'm including the 10. Had it been an open dot, I still would have used a parentheses, but the bracket is how we know in interval notation that we're including the 10. So this basically reads then like the set from negative infinity to, or I'm sorry, the interval negative infinity to 10, where we are including the 10. So 10 could be an answer. We could have 0, we could have 1, 2, 3, we could have a half, we could have negatives in there. But big thing about this one is we are including the 10. If you were to look at this one, if you want to try it on your own, pause the video, you could. But big thing about this one is we're going to have the closed dot on -3 because we have the or equal to with the -3, but then 5 will not have one because 5 doesn't have the or equal to on there. It's just a less than sign. So when we go to write this out, as you'll notice, we have the closed dot on -3, open dot on 5. So then we have to have the bracket on -3 because that shows that we're including -3 in our answer, but parentheses on 5 to show that we're not including 5 in our answer. So again, this would mean the interval between -3 and 5 where we're including -3, but we're not including 5. This one's funny. If you haven't seen that big R before, the R means all real numbers. So that would be the case then where you're shading everything on your number line because it's all real numbers. So then with that, we would just be putting negative infinity to infinity because it's literally everything. So the smallest number you can think of to the biggest number you can think of. So all our real numbers would be in there. Just a quick rundown of the reminders that we kind of talked about already. You use brackets if you'd have greater than or equal to or less than or equal to, or if you were just looking at a graph, you would use the brackets if you have a closed dot. The only exception to that rule is if you have a infinity or a negative infinity. You always use parentheses with those. And then you also would use parentheses when you have just a less than symbol or a greater than symbol without the equal to. Or that would be for if you have an open dot on the graph. And then your answer always represents an interval, so sometimes people confuse it with an ordered pair, but if it's interval notation, it's an interval. And just a little application, the way types of problems that you usually use interval notation for, it would be if they ask you for the domain of a function, the range of a function, if they asked you where a function is increasing or where a function is decreasing, all of those are things that you would have to give an interval answer for. So say that they ask me to find the domain of this function. Domain means what x's are represented in the graph, or if you were looking at an equation, what x values are you allowed to use with that equation. So this one we're looking at a graph, so it's basically what x values are represented by the graph. So you figure there's none of these x values, -10, -9, there's no graph there. The graph starts at x equals -3. And then it goes all the way forever. It's got the arrow on the end. So this then we would want to have -3 to infinity. And then you kind of want to ask yourself, do I include the -3? And you should, because it's a closed dot, which means that it's included on our graph. So then because it's included on our graph, we have to think, is that a bracket or a parentheses? It's included, so that would be the bracket. But then when we have the infinity, we know infinity, we can never use a bracket with infinity. We always have to use parentheses. So it should look, your interval notation then should look like this, and it basically is just saying -3 to infinity where we're including the -3. And then we never include the infinity because we don't know what number that is. There's no set end. Okay. And then range is kind of similar, except for that range looks at the y values. So this would be asking kind of what y values could you have in an equation, or what y values do you have on a graph? So then when we go and we look at the y values here, you're looking now up and down then, because y is up and down, your rise. So the y values, technically there's no y values down here in the negatives. There's no y values at 0. There's no y values at y equals 1. The y values start at 2. And then same thing, there's an arrow, so it would keep going on forever. So then we would want to include the 2 because of the closed dot. And then again, we can go on forever because we have the infinity. And again, you use the bracket with the 2 because we have the closed dot. but we need the parentheses with the infinity because we always use parentheses with infinity because we don't know what number that is. Like, it's not a number that has a solid end to it. Hope that was helpful for the intro to scientific notation. Thanks for listening.